Today we're studying the distributive property. Make sure to write the date in your notebook for these notes. We studied the distributive property earlier in the year, and we talked about drawing the rainbow arrows, and we're going to show that again today. But first, what we're going to do is we're going to look at some algebra tiles to help us understand the distributive property. So I made a funny looking robot with some algebra tiles. I don't know if you can see the whole thing. There it is. So we've got this robot. I don't know if you can tell. This is one of the purple rectangles, which is a Y, and the blue rectangles for the legs and this part of the head, we call those X rectangles, or we call those X tiles. The little ones are called 1 tiles or unit tiles, and then this big one, this big blue square, is called X squared. So what we're going to do is we're going to write an expression to reflect what we have in this robot. So the first question is, for robot number 1, our first question is, what does it take to make the robot? Okay, write that down. You're copying these notes in your notebook. What does it take to make the robot? Well, we can see that to make the robot, there's one of the X squared tiles. So let's write that down. One X squared tile. And we've got some X tiles, the legs and this little part of the head. So there's 3 of those. So we need to say plus 3 X tiles. There's a Y tile, so plus 1 Y. And we have 3 of the 1s for the eyes up here in the neck. Plus 3. Those are our 1s. 1, 2, 3 of them. That's why we wrote 3 there. Okay, so that's what it takes to make the robot. But what if I say that I want you to make 2 of these robots? What would it take to make 2 of these robots? You have to make them exactly alike. What tiles would you need? Well, one way to figure that out is to use the distributive property. First, let's write our question. What tiles are needed to make 2 robots? Instead of going ahead and making another one with tiles, we're just going to figure it out. We're going to figure out what we need by using distributive property. We know that to make 1 robot, we need an X squared, 1X squared. We need 3 X tiles. We also need 1 Y tile. And we need 3 of the little ones. But we're going to make 2 robots, or at least we're going to try to figure out how many tiles we need for that. So let's multiply it all by 2. So we can put parentheses around the whole expression and put a 2 outside. And that means we're just multiplying everything times 2 because we're making 2 robots. So now we can use the distributive property. You probably remember that distributive property means to take the number outside parentheses and distribute it, pass it out, so that all the terms inside the parentheses get multiplied by the 2 that's outside. So what are the terms that we have inside? Well, each one of those terms separated by the plus signs is a term by itself. So that's a term, that's a term, the 1y is a term, the 3 is a term. We have 4 terms, and they're all going to get multiplied by 2. 2 is going to go there, 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 and there to multiply. So we're going to do 2 times 1x squared, plus we're also going to do 2 times the 3x, plus we also have 2 times the 1y, plus we have our 3 right there, so it's going to be 2 times the 3. So the 2 got distributed out so that we're multiplying it times all of those terms. Let's go ahead and do our multiplication. 2 times 1 x to the second power, 2 times 1 is 2, so it's 2x to the second power, and that makes sense because if you need 1 x to the second power for one robot, for 2 robots you're going to need 2 of them, 2 of those big squares. Okay, 2 times 3x would be 6x, so we're going to need 6 of the x tiles to make 2 robots. We only had 1 y in the first robot, so we're going to need 1 more in the second. 2 times 1 is 2. 2 y's are needed for 2 robots. And the little ones, there were 3 of them. 2 times 3 is 6, so we'll need 6 of those little ones to make 2 robots. There's our answer. These are the tiles that we would need to make 2 full robots. Okay, so now what we're going to do is I'm going to give you a new kind of robot, and I want you to figure out what you're going to need to make more than one of these. First, I'm going to show you the robot, what it looks like. So this is going to be robot 2. Let's write robot 2, number 2. There he is. Okay, robot number 2. What does it take to make this robot? So first, for this robot we need 1, 2, 3, 4, 5 X tiles. Each one of these is called X, and there's 5 of them. So this is 5X. And then for the eyes, there's 2 of the 1, so it's plus 2. So that's a simple expression for this robot. 5x plus 2. But the question is now, what tiles are needed to make 3 of these robots? What tiles would we need to make 3 of those? We know what it takes to make 1, but in order to make 3 of them, we're going to need to multiply times 3. So go ahead and what I think you should do now is pause the video. See if you can take the expression that we used for one robot and use the distributive property, multiplying times 3 to figure out what we would need for 3 robots. Go ahead and pause it and try that on your own. When you're done, start the video again, and then you can see my answer. Okay, in the parentheses, I've got my expression that I need it, that shows me the tiles needed for one robot. But since I'm going to make 3 of these robots, I need to multiply times 3 and figure it out. 3 multiplies times 5x, so 3 times 5x. And 3 also multiplies times 2, so I'm adding 3 times 2. And now I've got 3 times 5x is 15x, so I'll need 15 x tiles, 15 of these x's, in order to make 3 robots. Plus I would need 6. 3 times 2 is 6. I would need 6 of the little ones, and then I would have enough tiles to be able to make 3 of these robots. So there's my final answer for the number of tiles, or for the kinds of tiles and the numbers of them, that I'll need for 3 robots.